Hi, this is Chong. This video is dedicated to SimOps or anybody who has interest in simulator programming with Laerdal LLEAP system. In previous video, team programming with SimDesigner demonstrated parameter synchronized oscillations by blending themes with trend. In this video, let's look into parameters compensations with sequential transitions. It is demonstrated with team programming, but this concept is applicable in scenario and handler programming as well. The video is team programming with SimDesigner, parameters compensation with sequential transitions. The purpose of sequential parameters transitions. This is the heart rate and SpO2 fluctuations of an induced suffocations and relief of suffocations in healthy adults. The SpO2 reflects ebb and floods of oxygenations, while with a different time sequence, the heart rate regulates cardiac output in compensating oxygen's delivery status. This video clip illustrates in events of respiratory crisis, SpO2 isn't the only responding parameters, and SpO2 and heart rate swing at unique pace, directions, and strength. In simulation, mimic the parameters motion will enhance the fidelity of patients' monitors in training. Demonstrations of team programming with parameters compensation transitions. In suffocation state, parameters swings need to consist of transitions reflect the gain in heart rate and the delay response in SpO2. For details of team programming, please click the above link. This is the initial stage for pre-brief orientation purpose. Click the gray box below to have a new state so suffocation state can be created. Open new state and transcribe the suffocation state from the written scenario into teams. In suffocations, sequence parameters oscillations is needed to express parameters swinging with compensatory and decompensatory characteristics. Let's begin with ECG and heart rate. The transitions allows heart beats reaches 110 beats per minute in 12 seconds. In compared to raised heart rate, there is a delay of desaturations prior to SpO2 fall progressively to 82%. So SpO2 delay was set here, followed with a transitional falling to 82%. Since there isn't any respiration rate and blood pressure transitions to replicate, they have to be programmed with physiological rationale. At current physiological state, raise of blood pressure is closely related to heart rate, and transition curve of exponential is set here. The raise of heart rate and blood pressure suggests both fight and flight and increase of cardiac output. louder reading volume and higher eyelid blinking frequency are said to reinforce physiological crisis. The delayed onset of these symptoms allow emergence of strenuous parameters. In subsequent state relief of suffocations, note the motions and parameters movement and replicate it with transitions and delay as if suffocation state. With this, a 3-state theme scenario with sequential transitions is ready for the trial runs. In trial runs of theme suffocations, upon suffocation's activations, heart rate raised to 100 beats per minute prior to fall of SpO2. As shown in trench window, each parameter has unique progressions. This may seem chaotic in the unsuspecting eyes, but it gives simulation parameters the fidelity touch. The relief of suffocation state is also programmed with parameters compensations. By replicate parameters swinging with clinical sense, the simulated parameters reinforce learners' immersive learning experience. That's all for this video in imitations of parameters compensations with transitions in themes. It coordinates series of simple parameters progressions and match high fidelity parameters behavior. In next video, let's explore substates programming to arrange transitions or complex parameters oscillations. Let's explore it with scenario design. Thanks for watching. Bye bye.